So once again, thank you for joining everyone and welcome, especially to our new members to iTelescope. My name is Christian Sasse. I'm the astronomer-in-charge for iTelescope. We do this for passion. There is Leigh Moore. He is our chief developer. So welcome.
Yes, good morning to you all. Yeah, from Australia.
From Australia. I'm from Canada, Vancouver at the moment. So sunny Vancouver and cold, probably cold Australia, isn't it? So,
yeah, very cold down here in Melbourne.
And dark Australia. What's your time?
Yes. Yeah, it's 4 o'clock in the morning. Yeah, 4:06 to be precise. And
yes,
as we say in Melbourne, if you don't like the weather down here, just wait 5 minutes.
Yes. And also I would like to call out a special thank you to our three helpers, and they are John, Sikanda, and Walter. Thank you to the three of you for always helping. They're helping with the recording and so on, cleaning it up. And that is so valuable. So thank you very much to the three of you. I think all three of you are here. I've seen Sikanda. I think I saw John. I'm not sure about Walter, but he usually is too. So thanks for that. Okay, let's get going. I'm going to share my screen now. So when you log into iTelescope, this is the screen that you would be seeing, right? So this is our welcome screen. You can see what we have. We have 24 telescopes that you can really control, and you have immediate image delivery. You really have full control over everything here, right? And look at everything we have. And then once you press join now, and you can have a demo account, you can go to login. So when you press login, you come to what we call the launchpad. That's what you see. This is the launchpad. By the way, Leigh is working on this and making a much better platform very soon. Very soon. Yes. Yeah. He's working like crazy. I can really tell you 7 days a week he is. Okay. So I'll expand this window a little bit. So what you see here is where the sun is and where's daytime. That's where I am, and Leigh is sitting there in the early mornings, right? And so the 5 dots there are our locations where our telescopes are. You can see how much illuminated the moon is. When the moon is apparently close to the sun, it is almost getting close to new moon, which is a great time for astrophotography. And that's exactly what happens when you look here. You can see that sighting spring in Australia. That's the local time, 4:08 a.m. And you can see this beautiful Milky Way. It's a great time, right? And then you can see all the telescopes. So what I did a little bit earlier, I actually used one of these telescopes just to do a demonstration. It's a bit difficult to do this completely live because you have to wait a bit, but let me show you what I did. So I clicked on one of these telescopes, and you can do that too. You can see what type of telescope it is, right? So you come to a menu here, and then I just scroll down here on the left side, and I went here to one-click image. Makes it very simple. You see, if you go here on one-click images, you have all these beautiful targets that you can do. And I did click here on this one called Helix Nebula. Press submit. I'm just going to do that now so you can actually see how easy it is. It's going to run now and do that. It's going to take color images. I did that earlier to save time, but that's all you need to do, right? And what I'm going to show you now is actually what happens to that. So the next thing, what I did is I went here on the left-hand side. I just clicked on my images because that's where your data comes in. You then come to an interface, and there, of course, because I've been using the telescope a lot, the folders are for all the different telescopes. And then I clicked on T32. That's to collect my images, right? And here is the object name for the Helix Nebula. It's called also NGC 7293. I just clicked on it. Wait a second. Oh, that live, that's funny. Wait, let me try that again. I just want to show that again. I don't know what happened there. Click again. And for some reason, oh, there it is. Sorry, it is here. I just enlarged it too much. I don't know what happened there. You see the date? That's today's date in Australia, right? That is in fact. And here are all my images, and you can see they're already calibrated. I won't spend too much time talking what calibration is, but it just means the darks, the flats, and the bias have all been taken care of. So all I did is I downloaded here I just clicked on these and I downloaded all the ones where it says FITS file. So that's a special format that we have in astrophotography, right? I left out the TIFF files, and there are 3 reds, 3 greens, and 3 blues. And that is because we take color images with color filters. It's much easier to combine. We also have a single shot color cameras, but I'm just going to show you how easy this actually is. So I did download these. I'm running a Mac here, so I'm just going to show you that. So I downloaded this in a download folder called T32, and I just did all that. And here are the 9 images that we were just talking about. They're all there, the 3 reds, 3 greens, and 3 blues. And then all I did was I opened a software, and it's one of my favorite ones. It's called Astro Pixel Processor, simply because it is very robust and very easy to use. For those of you who like to see the version I'm using the latest update here, the beta 22, okay? So all I did here is I first defined the directory, right? The directory is just where my resulting images are going to be, right? I did that, and then I imported these images. So I'm just going to do that quickly for you. I just click on the first, hold down my shift key, and just import them. So what are we doing here? So we've taken 120-second images automatically. So that's what we're doing right at the moment. I'm retaking that actually as we speak, right? So 3 reds, so that's 2 minutes each, so that's 6 minutes in total. And when you stack these images, the signal to noise ratio, that's what it's really about. Your noise goes down because it's so dark out there. It really is dark. You can't see the helix really by eye unless you are looking through a very good telescope. Viewing through a very good telescope, you can see it, but it's impossible to see it with the naked eye. At least for me, it is. And so we are just stacking them. We're getting one final red, green, and blue, and then so that's what I'm doing. I'm importing them now. I'm not going to do much explanation. There they are. You can see 3 blues, 3 greens, and 3 reds, and we're going to stack them now into single images. So all I'm going to do now is just click. Stacking is integration. That's what it really means. And I'm just going to say integrate, do it. Okay. So it's asking me for a name. So I'm just going to call this Helix. Let's call it, and this is a live session that we have here. So let's just do that. And it's quite remarkable what you can do with so little images. So it's just going to stack these very quickly. Whilst it's stacking, and this will only take a minute to do that, the Helix Nebula is really beautiful. You'll see that in a moment. It's what happens when a star goes to the end of its lifetime. There comes the famous gong. And here you can see, we have at the bottom, you can see there's a live blue, green, and red. They've been stacked nicely now, right? And if I click here on a double click on the red, you can see that's the red part of the thing, of the Helix Nebula. You can see it looks completely different, doesn't it? So this is going to be very interesting. Now I'm going to double click on the blue, and that also looks different. So you can already sort of imagine in your head, you can put all these colors together, what they're going to look like. I just go to tools now, and I just say combine these colors, right? RGB, okay? So I'm just going to import these, add channel, right? And here are the stacked ones. That's the stacked images that we now have in this special directory. I'm just going to open this and just do exactly that, importing them. That's all I'm doing here, just saying yes. And then all you say is calculate, and we're done. That's stunning, isn't it? That was so easy. And that's not bad if you think about it. It's 6 minutes of each, so it's only 18 minutes for this telescope, and you already get the distinct colors. And if you look carefully, you can see here there's the secondary already from the explosion. You can just make it out the secondary red. You can see clearly it's there already, even with so little exposure. And you can see the red is mainly hydrogen from the explosion. You can see the immense energy from that explosion. If you look carefully, you can actually see how it radiates out, right? So this was a star that came to the end of its lifetime about somewhere 650, 700 light years away from now. So whatever we see there happened 650 to 700 years ago. In the center, there is a bright star, and that is the if I remember correctly, it should be, this should be the dying star that is responsible for this incredibly beautiful star death, right? Let me just try and zoom out. I always have difficulties doing this live. For some reason, I'm zooming in now. It's always on the Mac or so. I don't know why. I just cannot find the right. Here we go. Now I got it. Now I got it. Zoom out again, right? And you can see how beautiful and easy that was. And that's just happened. We just took that a while ago. Right. So let's just close this window here. I'm just going to say yes. We close it. And by the way, I will give more sessions in future and show you much more again about imaging and so on. We are nearly ready with the 2.0 version of AstroPixel processor, and that's really a lot better. So let's jump right back now into iTelescope, into the launchpad. So that wasn't too difficult, I hope. At least, that's exactly what it's supposed to be. We just are running the images. I'm just going to show you that again. You see, there's my username, Christian. So it's running again. I'm just going to show you that. It's doing exactly what we just did, but it's just doing that live. So if I go here to system status, you see that? System status, you can see there's my name, and it's running. Everything is focusing at the moment and doing all these things in the background. It's taking image 1 of 9 and so on. And if I click here, preview last image, I can actually see, in this case, can I or can I not? Oh, it's probably just taking it. Yeah, it's coming up now. It's coming. There we go. There, that's the single image. You can see the single image. You can even see that must be the red part, and you can see the single image actually from the helix coming up there. So that's really nice. Isn't that exciting if we can see all these things live? Right. So having jumped right in, let's go to the beginning again and just explain how we can even get there. So you can see it's early morning there. We talked about the local time already. This is when the observatory opens and the close time. You can see here, this is at a current where the moon is. The moon is low because it's only 19% illuminated. It's very dark. It's coming to a very good time now of astro imaging. And the sun is just below that. You can see there's a small, if you look carefully, you can see a small arrow pointing upwards, which means the sun is rising. It's at minus 32 degrees. You see, so the apparent distance between the sun and the moon is getting quite tight, right? Beginning towards new moon. Then you can see which telescopes are available. Of course, as we go into the early morning, more and more telescopes are available, right? So that's just a quick explanation. Then we have the other tabs here, or the windows here are by default closed because at the moment the observatory is not open. For example, I click on Spain, you can see the local time is still daytime because we're in summer, right? And we're in August there, 2019, and very soon this should, if the sky is clear, should open. That's another site in Spain. You can see there. And then, of course, we have Chile. That's one of the best sites in the world, right? And of course, they are 3 hours ahead of Pacific time, which I'm on. Also, they're actually very much on Eastern time at the moment, which is 1419, right? So you can see that. Is that right? Yeah, that's right. It's UTC -4. That's correct. Yes. Okay. Of course, that changes when we have the time change because they are south from summer to winter time. Utah is really a great site. By the way, there's still a chance, if you don't know, Craig and I, Craig is the person who's running the Utah Desert Remote Observatory. We're running for the first time together, we're running a workshop, a masterclass together. So if you are passionate about astrophotography, you're welcome to look at that. There's a link on the main page to it. So if there's still, I think 1 or 2 places are left. So if you're interested, you can happily join. It's not too late, and I can promise it's going to be really exciting. It's a great place. It's very exciting. You can see all the telescopes too, and I think you'll gain a lot of knowledge that way. Right. So that's about Utah. So now you say, well, Christian, it's very nice. I don't know what T all this means, and I don't blame you. It's maybe something we should change in future, Leigh, right? Make it a little bit more. Don't you agree? We should make it.
Yes, yeah. The telescope designation numbers, T30. What's a T30?
Yes,
yes,
that's right.
We'll make it more user friendly in the future, so it's easier to know what you're looking at. Yeah, well and truly.
Exactly. So we know where we have to improve. So, sorry, now I lost it. Yeah, so you say that's very nice. I don't know what this means, or you've explained all this. I have no clue what targets. I'm new to astronomy. I really don't know. And all you need to do really is click here on Start Planning here, because that really helps you. The other thing, what you can just do is what I showed you earlier. You just go to one-click image, and you can just choose from the menu and just sit back and relax, and it'll do everything for you, right? Okay, so you come to the iTelescope planner, and you see all the observatories that I was just showing you. Well, let's go, because I've just showed you Siding Spring, let's do something different. Let's stay in North America, because tonight it's going to get dark very soon. August is usually a great month to image, right? So I'm just going to click on where? On Utah. Here we are. Let's just click on Utah for a moment. And to put in today's date too, it's the 11th, right? And I'm just going to say search. So what can we do in Utah tonight? Surprise, surprise, Andromeda crops up, isn't it? It's so that's the big galaxy right next. So I'm going to, Andromeda is just, I don't know how many times I've imaged Andromeda, but I just simply can't get enough of it. It's just so overwhelmingly beautiful. I know what it looks like, but I still have to do it again and again, right? And then you have the beautiful triangular galaxies, just comes up a little bit later than Andromeda, really beautiful. So you've got beautiful galaxies. And then, of course, because the Milky Way is rising now in North America, very nice. You have the North America Nebula, famous NGC 7000 coming up, which is really beautiful. All these beautiful targets coming up that you can then click on. The Pleiades are just becoming visible, right? So if you go down the page, you will find all these different targets. Well, I'm going to just quickly allow you to choose one of these targets, and let's see how we actually program a telescope to do this. So put it into the chat. Tell me which one you would like me to, and Leigh and I will do a rough count and see if we can figure out where the most votes go to. So I'll just name them: Pleiades, Andromeda, Triangulum, just some of the Pinwheel. Oh my God, how could I forget the Pinwheel? Pinwheel is magnificent, of course, yes. And so on. These are mainly all galaxies, but let's do that at the moment, yeah. So here we go. So let's look at a few. Okay. So Leigh, we have M33. Okay, so that's a triangle. The iris is beautiful too. The Pinwheel, okay, 101. 348, that's a good one, Nick. M45, the Pleiades. Okay, the Triangulum again. The Iris Nebula, Triangulum, M45. Oh, can you count so quickly?
Yeah, I think the Iris Nebula is just one. I think it's one ahead of
it's
the
interesting. The Iris has one. That is remarkable. We've never done that like that. And we have more coming in for M101, of course. Are we still on the Iris? You think so, Leigh? Can you have a quick count? Pinwheel pointing again.
Yes.
So just careful that you...
I'm pretty sure it's the Iris.
Okay, great.
Yeah,
so
the Iris has it.
Okay, the Iris has it. And Martin has quickly come in from Germany and says, now we're going to do the Iris. Okay, good. We'll do it. So we'll click on it. Great. So let's do that. So here's the Iris Nebula, also called NGC 7023, and I'm going to expand this a little bit. So you see here are the celestial coordinates of that. That's the right ascension declination. I will not explain where these come from because it just takes too much time, but trust me, they all mean something. They mean a certain position in the sky. What I can tell you in very easy terms, declination is really like your latitude. So I'm latitude 50 here, or 49 to 50 in Vancouver. That's like Paris, okay, Stuttgart, and so on. They are all on 49 latitude. So yeah, 49 latitude is actually quite a lot of major cities are on that. And this is 68. So this tells us it's really very north. It's very, very northern side. You can, so there's no chance that Leigh will ever see this from Australia. That's what I can tell you for sure. Okay. So then you have the rise time here. That's when it just gets above 30 degrees. Okay, that's a bit weird, isn't it? But that's where atmospheric conditions and also observing conditions from the wall and so on get good enough. So it says in the early evening you can start, and the transit time, that's the highest point, you know, like when the sun's in the south, on the northern hemisphere, or the north on the southern hemisphere, depending where you are. That's your highest point. And then you can see from here it's visible all night. You can see how large it is, right? 5 arc minutes, so that's relatively small. The magnitude, I won't go into that. And then the moon angle is quite far, but it doesn't really matter. The moon is so weak now. So we know that. So let's just click on this link. That brings us into a beautiful interface called Telescopius, right? So I see immediately that something has gone wrong here. I don't know, Leigh can probably see that too. So yes, it's not followed what I wanted. I went to Utah, but it jumped into Siding Springs. So it seems like the cache is still working. It's good that these things are going wrong, because if it wouldn't go wrong, and you experience it, you would be frustrated. So I went in here on the list here. You can see where it says Telescope Observatories. And I just scroll down and see here's Utah. So let's click on Utah. And this time it worked. Sometimes the cache just jumps back in. It happens. So then you have to go into incognito mode. I know I'm boring you now with all kinds of things, but if you get frustrated with this, sometimes Chrome does that. Just watch out, right? But now here, this looks much better because this is correct now, the correct observatory, right? And you can see this interesting graph here on the side, which looks very symmetrical, doesn't it? It looks very symmetrical. And that means you can observe it all night, because here you're getting in the golden hour. This means you can really, it's almost perfectly symmetrical. And yes, we can observe it all night. There's the 30-degree line is about here. That's the 0-degree line. You can do all kinds of customization there, which I won't go into, but this is completely free. So you can you can sign in and have an account here. Okay, so we know we can observe it all day. Which telescope do we take? So here, if you scroll down, this is your telescope simulator from the Iris Nebula. Okay, so it's not real, but it gives you a realistic perspective of what we can see. So if you click here, you can see it's already on iTelescope here. So if you click here on that dome, just click on it. All the telescopes are opening now, right? And you can see all the flags there. And we do know we're going to use Utah. So it's just, I'm going to use the US flag now. I'm not going to worry about our other one in Sierra, on the Sierra Mountain at the moment. I'm just going to click on it and see how that looks. And you can see there T11, when I clicked on it, you see how it's framed? Very nice. That's your virtual window of the telescope, right? And you can see the Iris Nebula, although it's quite small, fits in really beautiful. That's incredible blue and so on. So that would work nice. Let's try another one just for fun. I'm going to try T19 and click on it. And you can see the field of view is a bit different, right? And it would also fit in beautifully. So let's try T21. Also, that would work, right? So let's go a bit further, try C68, which is a color camera, single shot color camera. So that means it's like your DSLR, your mirrorless camera. You just take a picture and it comes out already in color. That's what it means. But there it's fairly small, right? And so that is obviously a much smaller telescope. It's much better for wide field, right? Probably not the best choice for this. I'm just showing you this so that you get an idea. Most telescopes would be very suitable. Let's take T14, and you can see T14 is actually a refractor. It's absolutely not suitable for this unless you are really wanting the whole field for whatever reason. You may have a reason there that a comet is passing or something like that, right? So let's go back then to a suitable telescope. T24, by the way, would also fit. That's our 24-inch. That would fit perfectly. My goodness. You know what? We should actually do the Iris Nebula once for premium images. It's so beautiful. I don't think we've done that before. I'm just thinking it's just amazing. So it's a great choice. We've not imaged it like that, right? Okay. So anyway, so you can see there are a lot of telescopes. Again, our apologies for the nomenclature, which is so difficult to understand. We will change that in future, make it much, much easier to understand. Okay, so we can choose T11, T19, T21, T24. We've got a lot of choices there. Okay, so we know now which telescopes we can use, and we know we can image it all day. Well, with that knowledge, that's all we need, because now we can go right back. 1 second, I just have to go to this main. Let me just go back into the main page here. We can go back here now, and we're going to open Utah, and let's just do exactly that. So you can see Utah, of course, is daytime right now. And okay, let's try T11, and let's see if it's actually possible. So I'm doing all this completely spontaneous, and seeing if we can actually do a reservation. So the first thing we have to do is we're going to do a reservation. So it's like a booking that is going to guarantee you that space, okay? So let's do that. Go to the left-hand menu, and you can see there's under imaging plan, you can also do the moon, excuse me, if you like. So under one-click images, it gives you more abilities to customize whatever you're doing. So I'm going to click here on deep sky objects, right? So we had the Iris Nebula, and I don't remember what the designation was, but we're giving it a plan name, and I'm just going to call this Iris, and I'm going to call it live at the moment because that's what we're doing here. And I'm going to type in the target name, and hopefully the database will pick it up and say look up, and it does. You see, it found the Iris Nebula, and there it is. And no surprise, it tells you when you can start imaging, when you can end. Everything is there for you, and the coordinates have already been populated for you. You don't have to do anything. You can now go back into Telescopius by pressing View Object Frame, but we don't need to do that. You can do that yourself because we have actually done exactly that. You see here, it's already telling you everything you need to know. The minimum target elevation above the horizon, 15 degrees, which is great. And the maximum exposure you can do is 900 seconds, which corresponds to 15 minutes, right? So let's go down and now populate these with some filters, okay? So you see all these different filters that we have. You have luminance, and you can choose all these different filters. Now, if you go to the Helix Nebula, if you think, now what are all these funny names here that they have? There's so many funny filters here. I thought you just need red, green, and blue because those are primary colors, and you can mix them. Well, you can take what we call narrowband. It's a funny word. It really means that you take single spectral lines, emission lines. If you remember the picture that we had from the Helix Nebula, you had this beautiful red and the beautiful sort of green blue. So the green blue in the middle is that's actually ionized oxygen. Okay, that's ionized oxygen. And so you could choose a specific filter in that case for the Helix Nebula that brings out this line in incredible detail, much more than you can just use, for example, if you use the green or the blue filter, because it's so that the green and blue filter will not give you the very sharp details. It'll give you the line plus the color, right? Whilst here you just get the single line, right? That's why we have hydrogen, which is the red. For example, a lot of the ionized hydrogen you would have in the Helix Nebula and so on, right? So when you take nebula, it's often very good to enhance the colors by taking out, especially if it's a hot nebula, of course. If it's a cold nebula, like a reflection nebula, it doesn't work. But for hot nebula, you can definitely do this very well. So that's what you take this enhancement for. Just to explain. So we're just going to take, in this case, luminance. Now, what is luminance? Luminance takes red, green, and blue together. It's like your old black and white picture. If you think of Ansel Adams in taking some beautiful pictures of the Grand Canyon, or so you've probably seen it. It takes these incredible, beautiful black and white pictures. So it has red, green, and blue incorporated. That gives you the details. That's why we have luminance. So don't forget luminance in this case. And then you can see quantity. I'm just going to put 1 here. And then how many seconds? We saw we can take maximum of 900 seconds. Usually 120, 180, or even 300 seconds is a very good, it's 95% of the time you're targeting right that way. So then you have binning 2. Now, binning is another strange thing. So leave it usually at binning 1 for luminance, because it just means it takes all the pixels individually of your camera. So every pixel is a signal, but we can also put them together to get more signal. You can do that. And that's when you choose binning 2. So for example, if I take red, the signal is not that great. So if I take a 300, I could now go to binning 2, right? Well, it's probably good because it will go a lot faster, because it's putting 2 by 2 pixels together. That's what binning means, right? You have 4 times the sensitivity, right? But you lose 4 times the resolution. But we're cheating a bit because we're using the resolution from the luminance filter, so we don't worry too much about it, right? Especially if we take quick images, that's not that important. I'm just going to replicate this now, what I've done above for green and blue. So let's just do that. There you go, 300. There we are. And that's, oops, I have to make 2 here and 2 there. That's, you see what I just did? It's when one is careless. So you really have to be careful. And it does happen to me. You have to be careful that your binning matches. If it doesn't, it's not going to be good because your signals don't match and so on, right? So be careful. So I did binning 1, 2, 2, 2, 1 red, green. So this would take 5, 10, 15, 20 minutes in total. Now, you could increase the numbers here, but there's another way of doing this. You see the repeat function here? If I enable the repeat functions, I can do this another 5 times. I'm just going to use this another 3 times to make the total time 60 minutes. So what is happening here? I could have done it here, but it's easier to do it there. So it's now taking 1 luminance. Then it's going to take 1 red, 1 green, 1 blue. So it's changing its filter, the filter all the time. It's just like a big wheel that's revolving and it's taking all that. And then it's repeating it again. That gives us more uniformity if we do it that way. Because imagine suddenly clouds come in. So we've done luminance, we've done red, we've done green, blue. And if suddenly a cloud comes in and just spoils everything, at least we have something. Now, if I'd taken just only luminances, made this 3 and so on, then we might have only a small part. And it also evens everything much better out over the sky, because as you know, the targets rise, go to the maximum point, and to the transit, and then they go down again. So it gets you much more even distribution if you do it this way, right? By the way, the telescope focuses for you. Your images are calibrated, everything's done for you, so you don't have to worry about all that. All you have to do is choose this. And then you can add rows if you wish to. You can go on, and I won't do that in this case, but you can carry on and put some narrow bands and whatever you want. Just leave I won't go into this at the moment, but just leave it at default, and then you can just create a plan for later, okay? So there you go. Now I have a plan that's called Iris Live .text. Okay, so let's remember that. So now we have written a plan, but now we have to somehow bring that to the telescope, and that's the next step that we're going to do. So we have to do a reservation. You see, make a reservation. Now here comes a little bit, so do we actually have some time? Yes, we do. That's very nice. So you can see we could actually image all night long. You can see here's information about the moon, but we really don't have to worry about the moon because it's so low. But you can jump anywhere ahead of time, up to 3 months. So for example, if you say there's an event happening on the 25th of October, I could do that. I could press on the 25th of October, and you can also book time here if you wish. Okay, I'm just going to cancel that, but you can go I had 3 months, okay? So let's just go back again to today's date, which is August 11th. I'm just going to press here again. So if so August 11th still exists for tonight. It doesn't exist for Leigh anymore because he's already on August 12th, but for us it does. And you can see, again, this is always in local time. Just remember, local time. Everything's in local time to make it easier. We don't use UTC time because it gets so confusing, right? But I think, Leigh, in future, we might introduce also that as an option so you can actually choose, I think, right?
Yeah, that is correct. Yeah, we can toggle between local observatory time and UTC.
And UTC. So for those who are more...
System.
Yeah, that's right. That's right. For those who are more experienced and need things in UTC time, you'll be absolutely able to do that. So I'm just going to now do the reservation. So I'm going to choose somewhere at 11 p.m. because there's a free slot. I'm just going to pull this along here. Okay, see that? So I'm just going to say here 11 p.m. And now the question is, how long should it be? Because you saw that when we were doing the Helix Nebula, it was taking quite some time from focus. So it's not just taking images, doing other things too, which take time. So the true answer is, of course, every telescope, it varies, but we have sort of, I would call it a rough average, right? A really rough average. And it's what it says here. We recommend a reservation of 1.5 times your total imaging time. For example, if your total imaging time is 60 minutes, which it is in our case, we recommend to do a reservation of 90 minutes. But in this case, you're only paying actually for for the complete run for the imaging time. I'm sorry, I meant for the imaging time. So how long it takes doesn't really matter. So that's why I chose from 11 to 12:30. Now we have to tell it what you actually want to run. You see, I have different options here from earlier targets. So I'm just going to say Iris Live is the one we want. You can put in a comment here. I'm just putting in this for training. You can also reschedule. So you see, it says if your reservation doesn't run, it will automatically book the same time slot on the first available night and so on. Okay, I just say confirm reservation. And that's it. That was easy. So here it is in golden color. You see all the others, your other members from iTelescope with reserved time are in green and you're in golden color, right? So if you want to shift this, you can even do that. I know it's not a lot you can do, but if you decide to shift this, you can actually shift your reservation, or you can even pull it a little bit closer to give time for others. It wouldn't make a difference in this case anyway. So there you go. And that's all that's needed. You're ready to go. And you'll get an email, and you can even go in and watch your run, but you don't have to be there. You can go to sleep or go out for dinner, whatever you're doing, and have a good time. That's it. Simple, huh? Hopefully it was simple. And then you have a lot more there to play around with, but that's the essential part of doing this, right? So that's going to run now. So maybe one more thing I'd like to show you also what is different. If you look at this, again, this is local time, and also the night of the 11th is seen as the whole night. We don't make the midnight line between, because that's why they put midnight as the day change, because people are sleeping, they don't worry it. If they put it as astronomers would love it, and that means during noontime, then the world would go crazy, except for astronomers. They wouldn't go crazy. They would love this, right? But we have to deal with the rest of the world. So that's why our change of daytime is at midnight. Okay, so just that's what it means. So we're talking about the night of the 11th. It goes all the way till the morning, right? Okay. So one more thing that's nice, you can delete it here if you want to, but there's another way of deleting it. So if you go back to your to the main page, let me just do, no, wait a minute, let me just go back again, sorry, go here, go back to the main page here. You can see there's some links here, some links that you have, and you can see here my reservation summary. See that? My reservation summary. And that's what I just booked. You see that? And you would be able to see all your reservations here, and you can actually delete it if you want to. And that's what I'm doing from here. And it's much easier to do that way. If you change your mind and you want to delete your reservation, you can do it from here. I think that more or less, let's see what our time is doing. Yes, I think that covers everything. So I'm going to stop the recording now. Hopefully that was clear. There are many other things about pricing and so on. If you're interested, we can maybe talk about that now in the Q&A. But let's not make it too long. So I'm just going to stop my share for at the moment and find my recording. One second.